Okay, basic differential rule. So I think we're not going to get up to rates of change. We'll save that for tomorrow. I just want to make sure that we can do the basics of taking derivatives. Today what we're going to talk about is constant rule, power rule, constant multiple rule, sine and cosine, sum and difference. We won't get to rate of change yet today. And then whatever that last one says. Oh, instantaneous velocity, it's a good one. Constant rule. Okay, so let's look at this. We have a constant function f of x equals c. C represents a constant, some number. Let's say, for instance, oh, I don't know, y equals 2. That's going to give us a horizontal line. Are we all in agreement on that? What's the derivative of that function then? Anyone? No? Why? Is that you, Jeff?
Yeah,
Why?
horizontal lines, overrise.
Right, so if you remember when we talked about the absolute value function, when we looked at the right-hand side of the absolute value, the derivative was 1 because the slope of that line is 1. On the left-hand side, we had the slope being -1. Now we're talking about a horizontal line which has a slope of 0, therefore when you take the derivative of it, you get 0. That mess is what's called the constant rule. It has its own rule. It's really not that exciting, but it does have its own rule. So I switched notations a little bit just so you can get used to it. I use that other one, dc of dx. So the derivative of the function c with respect to x gives you 0. No big deal. Anytime you take the derivative of a constant, you get 0. And then I've got a bunch of examples that are ridiculous because you're all bright enough to know that that isn't important, except why is number 4 0? What's that?
Pi is a constant.
Pi is a constant, correct. Just like if you take the derivative of e, you're going to get 0. Those are constants, even though they're represented with letters, especially a Greek letter. That one tricks people up a lot. Okay, now this one is the one we just covered here. So in fancy calculus speak, it's exactly what Will said there. If you want to take the derivative of x to the nth, you bring the n down in front, bring the power down in front, reduce the power by 1. You're going to do that so many times in the next couple months, you're going to just go crazy. So the rest of the slideshow does two things. Number one, it practices this. And number two, it then looks at the opportunity of putting a number out in front, like we did here, and talking about how to deal with that number, which we've already addressed also. You just multiply the two. You know this is really important because it says this is really important in bright red, and it flashes. Shall we? We shall. Maddie, what do you got? You forgot one small thing? 3. 3x squared, correct. 3x to the second. Bring the power down in front, reduce it by 1. Beautiful. How about this guy? Some problems that might be helpful for you to take the time to rewrite it before you take the derivative. ¿Dónde está señor Connor? No está aquí. No está aquí. Grace, how would you rewrite that before you take a derivative? Oh, I like it. Okay, so if we rewrite that as x to the 1/3, now what's the derivative?
1/3 x to the -2.
Ooh, very nice. Well done. For now, I'm just concerned about you getting to that point. later on we'll have to talk about whether or not that's an acceptable answer. Because you could rewrite this as 1 over 3x to the 2/3. Or if you want to get all fancies in your pantsies, you could write it as the cubic root of x squared. But for now, we just want that. If you can do that, I'm happy. Did I lose anybody in that one? Did Grace lose anybody in that one? We're good? Bring the power down, reduce it by 1. 1/3 minus 1 is negative 2/3. Lovely. How about that one? Tori, how would you start by rewriting the h of x?
X to the negative 6.
Beautiful. What's a derivative?
-2x to the 3rd.
Ooh, nice. Most people get tricked up on that and tell me that it's to the negative first, but -2 minus 1 is -3. Well done. And again, leave it in that form. I don't care about moving that to the bottom. You're fine. Anything tough about this? Nope? Good. We're going to go through this quickly. The only thing this says is if you have a constant out in front, just multiply it by the constant when you're done. So when, which one was it? This one. When Nick took the derivative of 3x to the 4th and gave me the answer of 12x to the 3rd, what he actually did is apply the constant rule. You're not going to do this, but this is where it comes from. It's actually 3 times the derivative of x to the 4th. Derivative of x to the 4th is 4x cubed, and then this is multiplication so that we get our 12x cubed. Again, you're not going to do that. You're just going to bring the power down and multiply it right away. But what allows you to do that is that what's called that constant multiple rule. Of these, the only one that's really worth mentioning, we did something like that already. We did something like that. We did something like that. Oh, how about this guy? How would you rewrite that, Caleb?
Sure.
How can you combine the cubic root and the squared into one exponent?
2/3.
Okay. That's a good start. Can I rewrite that further before I take the derivative?
I don't know.
Toria, you did this on yours before. How can I rewrite that?
Bring the x to the top of the x to the negative 2/3.
Good. 1/2 x to the negative 2/3. Okay, and that's before we take the derivative. All right, Michaela, back to you. Take the derivative of that now.
Negative 2/3 x over, or x to the power of negative 1/2.
Nope. 1/2 stays out in front. What happens to the exponent?
Gets subtracted by 1.
Good. What's negative 2/3 minus 1?
Negative 1/3. 1/3. I don't know. You're putting me on the spot.
Yeah, I am. Yeah.
Negative 5/3.
Negative 5/3. It's my job. Cancel. Negative 1/3 x to the negative 5/3. And again, leave it in that form. We don't care about getting rid of the negative exponent. We'll deal with that later. Okay. Question?
Why didn't you multiply negative 2/3 by 1/2?
I did eventually. I canceled the 2's. Got down to 1/3. Okay, I just waited to the end. That's that. Okay, so with derivatives, okay, let's back up. When we did limits, I kept saying this thing that if you want to find the limit of a sum, it's the sum of the limits. So take the sum. Sorry, try that again. Take the limit of one, take the limit of the other, add the two together. Then we did subtraction, multiplication, and division. For derivatives, there's only two, just sum and difference. You can't do product, you can't do quotient. Okay? In other words, the derivative of a product is not the product of the derivatives, only sum. These two rules are what allow us to take the derivative of longer polynomials. If I have something like x squared minus 2x plus 7, and I want to take the derivative, I just take the derivative of the individual parts. And what I'm left with is my final derivative. Okay, so for instance, Kevin, what's the derivative of that?
Three x to the second minus 4x. Or minus 1.
What's the function negative 4x look like? So let's just let's isolate this puppy. What's that look like?
A line.
And therefore its derivative would be
0.
nope.
Or the slope of the line.
What's the slope of that line?
Negative 4.
Bingo. Derivative of 5? Say it louder. 0. Why?
Constant.
It's constant. Okay, so that 5 is just going to disappear. That's just more of the same. Let's see if we got anything interesting. We don't. Okay. I'm not a big fan of this, but this is one of those points where we just say you just got to know this. So whether it's memorizing or writing it on your hand, I don't care. I've only done this once before, and that's with the sine of x over x and the cosine minus, or 1 minus cosine over x. This is another one. You just need to know that the derivative of sine is cosine, and the derivative of cosine is negative sine. It's not that bad, but the thing that's going to cause the problem for everybody is that pesky little minus sign. You're going to forget, does the minus sign go on the cosine or does it go on the sine? And I have no clever rhymes or any way for you to remember that other than just knowing that the derivative of cosine is negative sine, the derivative of sine is cosine. What's that? Nick?
0?
Nope.
Then 2 cosine.
2 cosine, correct. Yeah. Remember, there's no products.
Oh.
So just take the derivative of sine. When you're done, multiply your answer by 2. Quinn, what's that one?
1/2 cosine x.
Beautiful. Colin?
It's gonna be y is equal to x plus -1 or negative sign.
You got the cosine correct. What's the derivative of x?
Which is 1.
Just 1, right? It's a line, right? 1x.
Yeah.
And its slope would be 1. Okay. So y prime there would be 1 minus sine x. We're going to stop there. Okay. We'll cover this tomorrow. This leads us into, I'm sure I mentioned this earlier, but we will have 3 definitions of